So now that we had a chance to talk about ForkJoinPool and its key methods, let's turn our attention to another very important piece of the puzzle, which are the key methods in a ForkJoinTask. And as we saw before, ForkJoinTask implements future. So if you take a look at ForkJoinTask, you can see it's an abstract class that implements the future interface, and therefore it inherits all of those methods and it implements them. However, it's not common to use ForkJoinTask's methods, which are fork and join, but instead to use the subclass methods, most notably compute. And let's talk through this so I can give you an overview of what fork and join do, and then we'll talk about the subclass methods that do more interesting things. So fork enables a task to create subtasks that will run in parallel, and it does this by essentially taking the ForkJoinTask and enqueuing it into the deck for the calling thread and the calling thread and the thread pool that it is associated with, which is either going to be the common ForkJoin pool or some custom pool that was created by the user. The fork method doesn't block the caller. All fork does is it just plops the ForkJoinTask onto this deck and then returns right away. And then, as we'll see, that ForkJoinTask is executed in some clever way henceforth. Specifically, what it does is it goes ahead and pushes the ForkJoinTask, or subtask as it were, onto the deck that's owned by the current worker thread. So this, of course, is assuming that we're inside of the common ForkJoin pool or a ForkJoin pool and its worker thread pool. So when fork is called, it's in the context of a worker thread in that pool. If you're not in the context of the ForkJoin pool, then you have to use one of the ForkJoin pool non-ForkJoinTask client methods like execute, invoke, or submit to get the ForkJoinTask into the context of the ForkJoin pool. The join method returns the result of a previously forked computation when it's finished being processed. And the calling task is logically blocked until the underlying thread discovers that the forked subtask it's waiting to join upon has finished. And that's what I referred to earlier as the collaborative Jiffy Lube model of processing. So it doesn't really block, it logically blocks. In other words, the return value doesn't come back until the computation is done. But the actual thread that calls fork, the worker thread that calls join rather, will go ahead and pitch in and do other computation. Another key thing to remember about join is it defines a so-called synchronization point. And that means after the join is done, then any state that it's manipulated will be pushed out to other threads so they will be visible. So you can basically think of it as defining a so-called happens before relationship. So that means that any writes that take place in the worker thread where the join is occurring will happen before the join, happen before in such a way when join returns, all the other threads will see the results of that computation. So what this is saying in a nutshell is you aren't responsible for dealing with memory visibility and other tricky issues in the Java memory model. This is handled by the join implementation. Then finally, there's another method called invoke, which is sort of equivalent in some sense to the invoke method on ForkJoinPool. And what the invoke method on ForkJoinTask does is it performs the task, awaits its completion if needed, and returns the result. So it's essentially a two-way call, which, as you might imagine under the hood, calls fork and join to do its thing. It can also throw some exceptions. It'll throw a runtime exception or an error if the computations that are occurring under the hood happen to do so as well. So that's the end of some of the key methods in ForkJoinTask. Typically, again, you will not call these methods directly, but it's kind of useful to know that they exist and to be aware of what they do because it'll help to make a much deeper appreciation and understanding of how the ForkJoin framework works under the hood.